Our next presenter is Javaria Ahmad. She is working with Dr. Bulu and in the area of privacy and security issues in IoT devices. With that, we welcome her.
Is it sharing on Zoom?
Yes. Takes this one.
And you show me a 10 mark and if I go to presenter, is that
Yeah, but it
disrupt
doesn't
anything?
go.
Oh,
That's,
it doesn't.
that's my fault. Yeah.
We should try it. Okay, so 10 mark and
10 minutes.
okay,
But
50.
you have time. You're
Hello, everyone. My name is Javaria, and we have conducted this research together with Dr. Fanjun Lee, Dr. Bolu. And our research topic here is IoTPrivComp. That is to measure the study, so that is a measurement study of privacy compliance in IoT apps. That is, the IoT apps, do they comply with their privacy policies or not? The practices that it does, the capturing of user data, the sharing of user data from the apps that we use, do they declare properly in their privacy policies that they are doing those practices? We have published this paper a few months ago in ISRS. To talk about IoTPrivComp, I'll be going over this. First, I'll discuss the background and motivation of our work. Then what is IoTPrivComp? I'll go over the details of the framework, then evaluation and analysis of our framework, finally some case studies that came forward while working with IoTPrivComp, and then some discussion from our work. Currently, what are the challenges? Well, privacy policies are a primary way to communicate with the users about their practices. When you download an app, you look at privacy policies, okay, what the app does. But there are problems with privacy policies. The privacy policies are difficult to comprehend. Sometimes the language is so difficult that a normal user is not able to understand what the privacy policies are talking about. They're long, and many times the privacy policies, they are inconsistent with their practices. So the apps would be collecting data, but they would not declare in the privacy policies that they are collecting the data, or they'll be incorrect about the practices. They will be collecting the data, but they'll say they are not collecting the data. So they are inconsistent, or they do not mention those practices at all. To overcome the challenges that I have just discussed, there have been some research done in the past. This figure shows what research has been done. So privacy policy comprehension, to understand the number one here, to understand the privacy policies properly, there has been some work done to let the user know what the privacy policies are telling them through automation. So that work has been done about privacy policy comprehension. Then what the actual practices are of the app, that's number two, and what permissions the apps request while you're downloading an app, installing an app. So 2 and 3, the gap between these two has been studied as well. What we are doing is here, studying the gap between 1 and 2 through IoTPrivComp. Now, there are references down here that have studied the gap between 1 and 2. 1 and 2 is checking the privacy policies and what is the actual action of the app. These have been done, but only for websites and mobile apps. How we are different is we are checking this compliance for IoT apps. So first, we'll define what IoT is. Well, you all have been using IoT in daily lives, but what are IoT? Those are mobile applications that interact with IoT devices. IoT devices being your Philips Hue bulb, right? The watch that you wear. You go to work out and you wear your watch, it tells you your steps. Those are IoT devices. Also, Ring doorbell is another example of IoT devices. Problem here is why we thought that it's worth studying. The other mobile apps, yeah, they've been studied like WhatsApp. WhatsApp is a mobile app. But the data the IoT devices capture, that could be much more sensitive. Think about it. The watches you are wearing, it's capturing your ECG data, your steps, your geolocation. So all that, is it revealing without your information, without you knowing? Is it revealing your information to the third parties? So this is what we study in this study, IoTPrivComp. Also, the off-the-shelf tools for checking compliance, they were insufficient for IoT apps because they were checking mobile apps, web apps, so they had to be modified to work with the IoT apps. All this motivated us to propose IoTPrivComp. IoTPrivComp is a framework again for checking the compliance between actions of the apps and privacy policies, the declarations in privacy policy. And we aim to answer these three questions. The questions are, what is the overall landscape of compliance? When I say compliance, the match between privacy policy and the actions, app actions. So what is the landscape of compliance looks like? And what specific compliance gap exists in IoT apps? Are there any patterns? Maybe one practice is more commonly omitted from the privacy policy than others. So these kind of patterns, this was our aim to find out from IoTPrivComp. This is a figure of our framework. First, we did data collection. There are certain popular IoT platforms. They have a list of IoT devices. So what we did, we captured the list of IoT devices first from these popular IoT platforms. Then we looked for their manufacturers on Google Play Store. Then we captured all the free IoT apps from those manufacturers from the Google Play Store. And we added to it the wearable devices like your Samsung watch, because wearable devices, they are of specific interest to us because the data it captures. Our final data set had 1,951 IoT apps and 1,915 APK files. If you do not know, APK is Android package files, so they contain the code. So that we needed to reverse engineer to see what apps are actually doing. We also downloaded the privacy policies, right? So on one side we have the code. We also needed privacy policies so we can match the two. The privacy policy that we downloaded, 234 apps did not even have a privacy policy. So they're not declaring anything to their users yet. They are performing some actions. They're capturing the data, they're sharing the user data with third parties. And 228 apps provided non-English policies. Majority of them had app descriptions in English. So this is alarming. It looks like the apps work for English-speaking users, but these apps fail to declare properly the practices with their privacy policies. Then we created ontologies. What are ontologies? Using the privacy policies, created ontologies. Ontologies tell is a relationship between the words in a privacy policy. For example, a more generic term. So a more specific term is a part of more generic term. Like here on the right-hand side, you can see PayPal is a payment provider. Twitter is social media. Facebook is social media. We needed that relationship, or we needed to create ontologies to do semantic analysis of privacy policy. Because when we are checking compliance, we should know what PayPal is, what Twitter is. Sometimes privacy policies use generic terms, sometimes specific terms, so we needed to do that mapping. For that, we hand annotated a corpus of policies with data objects and entity objects. Entities are entities like we collected, we is an entity, or a third party, PayPal, that's an entity. Data object would be like your health and wellness data, voice data, your sensitive data. So we hand annotated and we trained a relationship classifier on that hand annotated data. We also fine-tuned a word model that extracted the entities and objects from the privacy policy, and then we applied our classifier on it, and that gave us the relationships from a big corpus of privacy policy, the relationships between all the entities and all the objects. For example, I already gave you example about entity ontologies, data ontologies. Voice is the personal information, health and wellness is the personal information. And this is a part of ontology graph we extracted. Information could be personal or non-personal, personal information types of health, wellness, video, audio, voice, etc. So this ontology was needed so we can do the comparison of the code of applications with these ontologies. Then comes the data flow analysis part, the part in which we analyzed the code. We use this component to identify sources of data, things of data, and data flows. Sources of data, so it's a source of data that flows, that takes some flow and goes to the same. Things leak the data. We prepared a machine learning approach to classify things. We added support for Android 29 API. The original, the older methods, I would say, used support for Android 4.2. We added support for much advanced APIs. We customized our code for IoT devices that was lacking in the past, and we made use of a machine learning approach that was much faster than it was done in the past, and it did multinomial night Bayesian. It provided much higher performance as well. And these are the categories of flows based on our code analysis. These are all the flows that are linked by those apps. For example, your email, your motion information, your audio, your video, payment, health and wellness data, social media data. So there are 21 categories that we identified were linked to IoT apps. Then comes the compliance analysis part, the consistency analysis. For that, we use the IoT specific ontology that I said we created. I mentioned 2 slides ago, we created that. We also adapted state-of-the-art NLP model. The previous approaches that did compliance analysis on mobile apps websites, they did not use this model. This BERT model is pretty complex model, gives much better results, and that's what we fine-tuned on our domain. We use that, and we can see the precision and recall was much higher as compared to in the past. In the past, they were around 85, 86, so that's the highest they could go in the past. From the consistency analysis, we saw that there are 5 types of disclosures. The disclosures could be consistent, where it's clearly stated in the privacy policy that they do some practice. That's clear disclosure. They are being upfront about it. They are okay. The disclosure could be vague, but still consistent, where they mention in vague terms that we collect your information, but they do not say what information. They do not say steps data. They do not say ECG data. So they are consistent but vague. The other disclosures are inconsistent when they fail to mention at all. The disclosure is omitted. They do not mention the practice at all, but they are capturing data. They are not declaring it. It could be incorrect, where they incorrectly state that they are not doing the practice when they are doing it. Contradictory disclosure is when the practice matches multiple statements in the privacy policy, but those statements, they contradict each other. One statement says somewhere we do not do such practice, and then later on it says we do a certain practice. For the performance evaluation, our classification approach gave a precision recall of 96%. The BERT model gave a much higher precision recall as compared to the past. The overall accuracy was 94% from our model, and we did that through manual validation. We got 68 IoT apps, random apps, and 100 flows, and we checked them manually. How many of them gave the correct results using IoTPrivComp? When we checked them manually, we saw 94% of the times IoTPrivComp gave correct results. It's a much higher accuracy as compared to in the past. The closest work that is there is called Polycheck, that works with mobile apps. They go up to 90% accuracy. So using a BERT model, our approach, we were much higher. Policy availability, what was concerning, there are many apps with missing policies. There are broken URLs, pages, if you click on the privacy policy page, some other page, the relevant page. Also, non-English policies were 228, 11.7% of the apps had non-English policies. But their descriptions were in English for 160 of them, so their policy should have been in English. The flows or the practices, we extracted around 23,000 of them, and 1,782 flows were pertaining to those 21 sensitive categories that I showed you, right? That we did classification of the data types, health wellness data, motion data, audio data. So 1,782 flows were from those 21 categories of data flows, sensitive data flows. For flow level compliance analysis, we see that for IoT apps, so that's how we read that for IoT apps and wearable apps, we reported that separately because wearable apps, they are IoT apps, but they are specific imposters, right? Because of the sensitivity of the data. IoT apps, the first party IoT apps, there were 62.5%, they were inconsistent. IoT apps for third party. Now, first party is when the app itself collects the data. Third party means when the app sends the data to another third party entity, like PayPal for payment information. That's third party disclosure. Third party flows inconsistent, like sharing of data with third parties. We found 78.2% of them were inconsistent with actual practices. Wearable apps, 62.7% data flows, first party data collection, they were inconsistent. They were collecting the data, but they were not disclosing in the privacy policy. For third party wearable apps, 77.8% were inconsistent, and majority of the inconsistencies are of three types, right? But the majority of inconsistencies were omitted. They were not disclosed in the privacy policy at all. When you look at app level, IoT apps, there were about 74.5% omitted disclosures. This 306 out of 411, they have omitted disclosures, and they did not declare at all in their privacy policies. For the wearable apps, we had 96 out of 121 wearable apps that had omitted disclosures, where they failed to disclose the privacy practice in their privacy policies. Certain case studies came forward when we used IoTPrivComp. This app from Google Play Store, all these apps are Google Play Store. So this app, it works with smart bracelet devices, wearable app. It collects data about the steps taken, but in privacy policy, it says it makes a generic vague statement that it collects user data. So it's still a consistent disclosure, but it is vague. They do not mention anywhere the steps taken particularly. There is another app used with wearable devices. They have omitted disclosures. They capture the ECG data and they share the ECG data with third parties. They share the geolocation data with third parties, but they fail to mention that in their privacy policies. So this is omitted disclosure. This is an inconsistent app, or it doesn't comply. Another case study is for was done for this app, which is used to monitor alarms, lights, and shutters in your home. And there are APIs that we found from code analysis that were collecting motion sensor data, but from the privacy policy description, app description, we did not find any functionality associated with that. So they did not disclose that they were capturing motion data, but they were. So to wrap up in the discussions, the conclusions that we got from this, from using IoTPrivComp, there are still significant compliance gaps that exist today. Even though there are regulations like GDPR, there are California law. I mean, with all of that, there's still compliance gaps, and that's concerning. The privacy policies itself, they are unavailable, difficult to comprehend, inconsistent in another language, so they fail to disclose properly to the users what practices are there for the apps. We found that majority of the inconsistent disclosures are omitted where they do not disclose at all. What practice is being done? Certain types of data. So in the beginning, I said we are also looking for patterns of disclosure. Certain types of data are more prone to being omitted, such as location, social media, health and wellness data. This was omitted a lot in the privacy policies. Also, we would think that developers would be more sensitive when writing the privacy policies for the apps that capture sensitive data, but we did not find such pattern. So this needs a lot of work from the developer, from the compliance agency, making sure that properly these actions are declared in privacy policies. So our contributions, finally, there are threefold. First, we conduct a measurement study to identify the compliance gaps in IoT apps. This is the first attempt at this scale. We had 1,951 IoT apps. There's another work that does the compliance in a very limited number of apps, only 11 apps manually, and just a subset of apps. So this is done first time at this scale. Also, we developed our own tools or refined other tools to work with IoT type apps. And also, we were able to report the inconsistencies, the compliance violations in those apps, and we found the patterns. In the end, we would like to thank our sponsors and the reviewers when we're submitting this paper, anonymous reviewers. And as I said, we published that in the ISRS conference. Thank you so much. I'm ready for any questions.
Thank you. Any questions for
The apps that you studied, were they all from the American Play Store, or did you use like other Play Stores?
From
Like
American.
European Play Store,
Oh,
your countries.
so here, American Google Play Store. That's what we from.
And so are you based the leak of data was based on mostly also American laws on privacy, or was based on more global approach?
Well, we studied both the laws, GDPR in California, and according to that, so you can see we did both. According to that, whenever there is a violation, we reported that it's a violation, because both of them say that whichever practice you do, you should declare it in the privacy policy. So that we checked and we marked as violation if they didn't. So both.
And so all of this was Apple.
All of this.
It was asked on the phone.
Apps, these are IoT apps, correct. So these apps, there are two types of IoT apps, right? That are installed within IoT devices, and another apps, those are mobile apps, but they control the IoT device, right? So these are mobile apps, but specific category of mobile apps that control IoT devices. So yes, these are the apps that you would install on your phone, on your tablet, so this. Like to control Philips Hue, right? So this is an app you would install on your phone, or to control Ring doorbell. So this.